Rolling.
Okay, so we've been talking about Newton's first law of motion, right? And that first law of motion tells us that an object stays at rest until it's acted on, or it stays in motion until something acts upon it. So I have this eraser, and if I just leave it sitting there on the desk, what's going to happen?
It's going to stay.
It's just going to sit there on the desk. But if I hit it, what happens?
It moves.
Moves. What makes it stop moving? Do you know? Do you remember? What do you think?
Friction.
Friction, you're right. So the friction of the table and the friction of the bottom of the eraser keeps it from it slows it down, right? What if I kick a ball across the grass? What happens?
It's gonna keep moving.
Keep moving
Until someone stops it.
till someone stops it. What else could cause it to stop? What?
Grass.
Grass, and the grass causes
Friction.
friction. Very good, which is one of our important keywords today, right? So today we have all of our vocabulary up here on the board, and so I want you to just read through those quietly because we're going to use those today. Just read through those vocabulary words. It's okay, we're going to go over them together. We'll read them together out loud. So in case any of you didn't know how to say correctly, we're going to say them together, okay? So, after I say it, you repeat it behind me so we make sure we say our words correctly and we know how they look and how they're spelled, all right? So, gravity,
Gravity.
speed,
Speed.
velocity,
Velocity.
weight,
Weight.
mass,
Mass.
inertia,
Inertia.
motion,
Motion.
balanced force,
Balance. Force.
and friction.
Friction.
Very good, very good. So today we're going to use our vocabulary words and what we've learned so far about Newton's first law of motion, and we're going to do a little experiment. So you guys have your paper. I want you to write your name on the top right hand side of your paper, and then we will write out our experiment. So just your name on the top right hand side of your paper. Okay? Now, when we do an experiment, or when a scientist does an experiment, there's always a question. He's always trying to answer a question. So today, put on your scientist hat. You're all scientists today. Good, you got your scientist hat on. So our big question today, and this is the first thing you'll write on the top of your paper, you'll write question, and then I put these two little dots, and then we'll write our question. So take your time. Just write the word question, just to start. Good. Does everybody have the word question written down?
No.
Okay. And now, to start the experiment, like we said, a scientist has to have a question. If he's going to figure out something, he has to have a question to figure out. So our question today is, will the block fall in the bucket? That's a strange question, huh? Will the block fall in the bucket? So go ahead and write your question down. What kind of mark should be at the end of our sentence?
Period.
No, if it's a question, it's a question mark. Good, good. Take your time. Make sure I wrote everything up there so you can spell it correctly. Now, I'm going to tell you what the experiment is, because the next part of the experiment is your claim. What you think will happen based on the idea of the experiment. So you haven't seen the experiment yet, but you kind of have an idea of what you think is going to happen, right? So if our question is, how long does it take to cook chicken strips, you kind of have an idea, but you don't know for sure, right? Okay, so on our claim, you can go ahead and write the word claim down and give yourself some space. Write the word claim and your two dots again. Your claim is what you think will happen. So today, let me get my stuff and I'll show you what we're going to do. We've got this bucket here. Okay, you guys all see I brought my big laundry basket in. Okay, and then we've got some blocks. So what we'll do is one by one, we'll run past the bucket. Okay, that's why we're in a big room, so we can run past the bucket and then drop it in. Now we're not going to throw it in the bucket, we're going to drop it in. Or we're going to try to drop it in. Do you think it's going to go in every single time we run past? Maybe. So
If we drop at the correct time.
there you go. See, you're thinking. What else? What else?
If it doesn't bounce out, like if you drop it too hard, it'll bounce out sometimes.
Good. Caleb, do you have anything? You have a claim? You think anything's going to happen? You think you get it in the bucket every time?
You can try.
You're going to try to get it in the bucket every time? Cole, you have a claim?
You can probably get it in the bucket maybe nine times out of 10.
You think it'll go in the bucket 9 times out of 10? Okay, so Callie is I'm gonna have her demonstrate the experiment for us really quick, and then we'll write our claim. Okay, so I'm gonna set it up and then I'll tell you. Okay, so Callie's not gonna throw it in the bucket. Okay, we're gonna set the bucket right here. All right, and Callie's gonna start right here. Can you guys all see her? Okay. Now, you decide what side of the bucket you want to run on. Are you right-handed or left-handed? Okay, so she's going to run on this side of the bucket, and you're not going to slow down, okay? And I'm going to stand right here so you know when you're close to the bucket, and you just keep running past, and then when you get right where you can stop, you stop, okay? So, ready, set, go. Good. All right, perfect. So that's what we'll do. We'll all each do that. And then we've got the iPad today, so one of us can record and take turns seeing what happens. Do we understand? Okay, so write claim on your paper. Go ahead, Callie, go back to your desk. And write what you think is going to happen. And think about your key words that we have. Gravity, speed, velocity. Callie, you said depending on if you drop it at the right time. What's that going to depend on? How fast or slow, right? Weight. If we were to do that with a bouncy ball, what would happen?
It bounce out.
Bounce
'Cause it's
out.
linked to them.
Yes, so think about your claim. Think about using your words. You can even put in there if you don't think it's going to land in the bucket. They got their claim down. I'm going to grab the iPad and get it turned on. Who would like to film first? Kenzie, you would like to film first? You don't have to mute. Stay in your chair. I'm trying to get it to turn on. It doesn't want to turn on. Technology's great until it doesn't work, huh? Okay. Go ahead and get your yellow block. And let's make a line right here where Callie lined up at. Callie, you get to go again. That'll be fun. Can we line up tallest to shortest? Can we do that? Tallest to shortest? Tallest to shortest.
I thought it meant
Yeah,
shorts
good
too.
job playing this one.
Callie's the shortest, darn it. All right, Kenzie, let me you can use my phone instead. How's that sound?
Yay.
Okay, so let's turn on the video feature. I'm going to hold your ball. And let's go right here. So you can videotape our first runner. Caleb, you'll probably have to back up there because that's probably not enough space for you. And I can move the bucket. But when it's time for Caleb to go, and I'll say go, that gives you a little more room. I'll say go. And so you start on Caleb, and then you videotape it all the way to the basket. You're going to run on this side, right? Okay. I'm going to try to get out of your way. You ready? Oh. Video problems again. Ready? Go. Oh, what happened?
He missed
He
it.
missed the bucket. All right, Caleb, will you videotape for us?
going too fast and couldn't drop.
He was going too fast and he missed. So that tells us something. That tells us something that speed is important. Thank you, sir. All right, Cole, what side are you going to go on? This side? Okay, I'm going to scoot the bucket over so a little more room. All right, go for it. Oh, speed is still important. Cole missed. He threw right over the bucket. All right, Kinsey, are you ready?
Can I go this way?
Oh, Cole's coming to videotape. It's his turn to videotape. You're all right, you're all right. All right, now remember, we know that speed is important, but you still have to run fast, okay? Ready? Go. Whoa. So, what did we see Kinsey do after she saw the boys go fast?
Slow down.
She adjusted her speed. So speed is important to see how far something goes. So when it landed in the bucket,
It bounced a little.
it bounced a little. So think about what else you saw. Okay, we don't have to tell everything we saw just yet, but think about what you saw. All right, Callie, you're gonna last one. Nicole, you want to videotape her too? Good job, Callie. Are you back over here?
Everything's trying to focus.
Now think about what you saw. So your evidence is what you saw in the experiment. So when you and you can use everybody's name in the experiment, and you can say what you saw. Okay. Okay, and after you've written evidence and given yourself a little bit of space, I want you to stop because then we're going to write reasoning. I'm going to have you do these two parts without me walking you through it because I want it to be your own thoughts. Write down your evidence, which is what happened in the experiment. Then you write your reasoning, and your reasoning is, was your claim right or wrong, and why or why not? So if your claim was correct, why was it correct? If your claim was incorrect, why was it incorrect? What could have been different? What would have needed to change? What do you got, Callie?
Mine was correct and incorrect.
It was correct and incorrect, so then you need to explain that. So if part of it was correct and part of it was incorrect, you still need to explain that. Because if we're a scientist, if we still have our scientist caps on, sometimes we're wrong and sometimes we're right. But sometimes we get parts right and we get parts wrong, and we have to figure out how to get completely to the correct answer. Does that make sense? Okay. Try to remember to use our words like gravity. What was the gravity that acted on that ball? What happened?
Falling down.
When it fell down? And what happened when it hit inside of our bucket?
It bounced only a little.
But then it eventually
That
stopped. So the gravity, it stopped. Our speed, we talked about that, was important. Right? And velocity, that was important, how fast we went. The weight of the ball, we didn't really talk about that, but we can know that if it had been a bouncy ball, it wouldn't have stayed in our bucket, right?
unless we were like walking and just like
Barely put it in the bucket, yep. But today we didn't use a bouncy ball, and we talk about friction, what friction inside there, what made that stop, right? Okay, so I want you guys to finish writing those out. And then we'll go over them. Take your time. There's no reason to rush. Scientists think long and hard about what they have to say.